do some practice with multiplying some polynomials and get you guys off and running to the races with some problems to practice on. Then we have our quiz on Monday. So tomorrow will just be like a review day, so I'll throw some more problems at you guys in this section just to do some practice. And then if you have any other questions, make sure you're asking them tomorrow. Right? And then Monday we'll have a quiz on this little section. And then Monday we start our new school schedule, right? So we'll still be here, same time, same place. All right. Ready to get the show on the road? So what are we on? P.4b. Looking at some polynomials. What's the word poly mean? Many, right? So when it comes to our little polynomials, remember we had monomial, which was one term, binomial, 2 terms, trinomial, 3 terms. And we could have how many ever terms we really wanted to have in there. So yesterday we added and subtracted. So today we're going to bounce up and we're going to do some multiplication. So we're going to multiply polynomials. So starting off nice and easy, kind of building on our little strings. If we had, let's say, negative 8x to the 6th times 5x to the 3rd. So on these we just, I do them whole numbers to whole numbers, and then our variables to variables. So negative 8 times 5 is going to give us negative 40. And what are we going to do with our exponents? Are we going to add them or are we going to multiply them? Anybody remember? Yeah, these ones we add, right? Because it's that power, or sorry, the product property. Yep, so it would be the 6 plus 3. Just writing it all out. So negative 40x to the 9th. Okay? And if you couldn't remember if we added or multiplied our exponents out, like, takes a little extra time, but you could have wrote all the x's out.
You Mrs. Fitch?
There, it should be popping up now. You guys good? Alright. So technically x to the 6th would be 6 of these little guys, right? X to the 3rd would be 3 of them. So how many do you have all together? You got your 9. So if you forget if you're supposed to add or multiply them out, just kind of do a quick little evaluation of all of the exponents, and hopefully that'll help you. Alright. So let's try getting a little more fancy. What if we had 3x to the 4th, and then in parentheses 2x to the 3rd minus 7x plus 3. So this here's a polynomial. Right? What kind of polynomial is that? Is that a monomial, binomial, or trinomial? So in a monomial with the degree of 4. And then we're going to multiply that to a trinomial, right, with a degree of 3. So we just got to make sure sharing is caring, and in Mrs. Fitch's math class we share with everybody. So this 3x to the 4th we have to make sure we share with everybody, right? So some people like to write it out the long way and like write it out piece by piece, but I think we're just going to try and see if we can put it all together. Sound good? So same thing as above, right? Your whole numbers to whole numbers and variables to variables. So 3 times 2 is going to be 6. X to the 4th times x to the 3rd is going to give me x to the 7th. 3 times negative 7 is going to give me negative 21. X to the 4th times x is going to give me x to the 5th. Three times 3 is going to give me a positive 9. Then I got x to the 4th, and there isn't any other x's, so I'm just going to be with x to the 4th. Not too shabs. You can also do what we call that area model on these. Whoops. To where we know we have one term here, so we'd have like a 1 by 3 little box. So on the outside you'd have your 3x to the 4th, and then on the top of the box you'd have like 2x to the 3rd minus 7x and then 3. And then you're doing kind of like that Punnett square or that area model to fill in each little piece. So this one's going to give you 6x to the 7th. This is going to give you negative 21x to the 5th. And this one's going to give you 9x to the 4th. All right? And you're going to get the same answer. So sometimes it's not so necessary to do it with like if you just have a monomial on the outside. But it's another option. All right. Ready to spice it up a little more? Feeling spicy today? Let's go with 2x plus 3 times x squared plus 4x plus 5. So here we have a binomial times a trinomial. So when we go to use our distributive property, we have to make sure that we share with everybody. So there's 3 different ways to kind of do this problem. It goes back to that personal preference. You can try and sometimes we call it like the FOIL method or the distributive method, to where you're going to go 2x times x squared, 2x times x4 or 4x, and 2x times 5. And then you have to do it with the 3. And then you got to share the 3 with everybody, right? So sometimes people can do it kind of like how we did this one. We just kind of went step by step, or I guess this one, right? We just went piece by piece and write it out. You can write it out to where you're actually writing it to where you're saying 2x times x squared and then 2x times 4x, so a positive 2x times a 4x, and a positive 2x times 5. And then now you've shared your 2x with everybody, so now you have to share your 3 with everybody. So you have a positive 3, so a positive 3 times x squared, a positive 3 times 4x, and a positive 3 times 5. Right? And then you can go through and you can simplify it. The other way you can do it is you can do that area model again. So when we go to make our area model and we go to make our rectangle, we're going to make our rectangle a 2 by 3 because it goes by the number of terms. Oops. So we're going to put our two terms on this side. And if you want, you can even throw the little positive there so you know to keep them positive. And then on top you would have your x squared plus 4x plus 5. Okay. And then you're just going to go in and fill in each one of these, right? So we get 2x to the third, 8x squared, 10x, 3x squared, 12x, and 15. And if your polynomial is in that standard form from that highest degree to the lowest degree, if you do the area model and you go to combine like terms, the nice thing is they usually will always show up on diagonals of each other. So sometimes when I do these problems, if I do them as an area model and like these diagonals aren't like terms, I kind of take a moment and I just kind of go back to sit there and make sure that I multiplied it right. It's kind of a little bit of a check. And then if we combine our like terms, we have, what do we have? 2x to the third plus 11x squared plus 22x plus 15. And if we go through and we combine all these terms, we're going to get the same answer. Right? So it's just kind of a personal preference on how you want to multiply them out. More than one way to skin a cat, right? All right. Let's spice it up by adding, well, let's try, You guys are falling asleep on me out there. Give me something. Let's go x. You want positive or negative? Positive. And then give me a number less than 10. 7. You guys always pick 7. That's funny. And let's say we take that to the third, right? So if we have something to the third, that means we're going to take that x to x plus 7 and we're going to multiply it out 3 times, right? So this is the same thing as x plus 7 times x plus 7 times x plus 7. So we're going to take our time and we're going to go piece by piece. So the first thing we're going to do is you're going to multiply like these two together. Or if you don't want to multiply those two together to begin with, you can multiply these two together, right? When it comes to multiplying, order doesn't matter. So we're just going to start with the first two. So if I multiply these together, I'm just going to use my distributive property. I'm going to get what? Whoops. X squared plus 7x plus 7x plus 49. We good with all those? So then we can just simplify that down to what? X squared plus 14x plus 49. Now I'm just going to throw that in parentheses for poops and giggles, because I still need to multiply it by my x plus 7. Could I put that x plus 7 in the front if I wanted to? Absolutely. You could put it up here if you wanted to, right? Because when you multiply, order doesn't matter. So here again, now I need to either use my distributive property. Yes? I have to share this x. Whoops. So that's x squared. That would be 7x. So that would be the first one. And then now I have to share this 7. So there's my other 7x. And 7 times 7 is 49. Okay. So now I have my little binomial times my trinomial. Right, this guy times this guy. So again, I can use the distributive property, but I need to make sure that I share my x with everybody. And then I have to go through and make sure I'm sharing my 7 with everybody. Or I can do the area model. So you guys want to do distributive or area? Distributive? All right, we'll try it. So I'm going to start by sharing my x with all three of these guys, right? So x times x squared is going to give me x to the third. X times 14x is going to give me a positive 14x squared. And then x times 49 is going to give me a positive 49x. Everybody good with that one? Oh, hold on a second. All right. So now that I shared my x with everybody, now I'm going to take my 7 and I got to share my 7 with all my other terms. So I'd have what, a positive 7x squared plus 92x plus, what's 49 times 7? So I'm going to cheat and I'm going to do 50 times 7 because I know that's going to be 350. And I'm one too many 7s, so if I subtract the 7 off of that, I'm going to get what? 343? 343. Yes. Oops. You're right. I was seeing if you guys were awake today. Good eye. Alright, thank you. And then now we just need to go through and kind of combine like terms. So if we start with x to the third, do we have any other x to the thirds? Nope. So we got x to the third, right? Now we can go with our x squareds. How many x squareds do we have? We got 21x squareds. Then we can look at our x's. How many x's do we have? Is that 147 x's? And then how many whole terms? 343. And then I'm in that standard form right from highest to lowest, which makes it a little more manageable for us. Not too bad. All right, one more example. So far we've just dealt with one variable, like we just dealt with x. So technically we could have more than one variable in our problems, and the process is exactly the same thing. So let's say we have 3x minus 5y, and we multiply that with x plus 4y. So again, we can either use our distributive property or we can do the area model. Right? So since we did the distributive on the last problem, I'm just going to do the area model just to spice it up and change things up a little bit. So if I go to make my rectangle or my box, I got 2 terms on this one and I got 2 terms on this one, so I'm making a 2 by 2 square or a 2 by 2 box. So we're going to put our terms on the outside. So I'm going to go with 3x minus 5y on this side. And it doesn't matter if you put it on the top or the side. That's your own personal preference. And then I'm just going to put x plus 4y up on top. And like I said, it's up to you guys. Like, you can put him over here. You can put these guys that you put on top, you can put it on the bottom. Whichever way makes sense to you. Right? You just got to have like one on the horizontal and one on the vertical. So let's fill in the inside. 3x times x is going to give me 3x squared. 3x times 4y. 3 times 4 is 12. X times y is xy. And I just put them in alphabetical order, so when I go to combine terms, it's just easier for me to spot. And then I'm going to multiply these guys together, and I'm going to get negative 5xy. Then in my last box, I'm going to get negative 20y squared. So I'm going to go through and combine like terms if I have any like terms. I only got the 1x squared, I only got the 1y squared, but I got some x and y's here. So I'm going to get 3x squared plus 7xy minus 20y squared. You guys good with that one? We all good where everything comes from, all of our terms come from? Alright. So you guys want to try a couple on your own? So on the Google site, there's a couple problems on there for you.